hour after the lunch, which is not an easy task, especially with the slides that I prepared for you. My background is engineering, aviation engineering. I did aviation study in Toulouse, France. And from France, I moved to Australia to work for Thales Air Traffic Management. I heard Thales' name in the presentation in Estonian, but I don't know what was said by Thales. So I worked on ADSB and data link for Thales, and then I returned back to France. I established my own company, so I know what's having new companies and trying to enter the market. And because the taxes in France, I decided to go back as a normal salary. So I applied for a job at Eurocontrol, and since I've been working for Eurocontrol for the last 10 years as a project manager. So for today, what I'm going to speak about is Eurocontrol. Small presentation about what we are doing at Eurocontrol, some few slides. And then I will speak about the air traffic management in Europe. But the main subject of this presentation is the airport domain. What are the challenges that we have at the airport domain as operational, and what we are expecting from the industry to respond to those challenges. And at the end, I will speak a little bit about the CESAR program, which is a huge program that we have in Europe at the moment. So, Eurocontrol history, it started in the 60s, 1960, exactly, with just 6 states on the west of Europe, southwest of Europe. And then 3 countries joined Eurocontrol in the 70s. It was mainly Turkey, Portugal, and Greece. In the 90s, we extended to the north and to the east, mainly the European countries. In the 2002, all the European Council signed an agreement with Eurocontrol, so all the states except Estonia joined us. In 2010, we had Latvia, the last state who joined Eurocontrol. So you see that there is only one country which is not in Eurocontrol from Europe, is Estonia. Another picture to give you an idea about Eurocontrol is a civil military organization, which is objective is mainly to manage or to build the European single sky. This was the main objective. But today, Eurocontrol is doing more than that. I tried here just to show that we are not only concentrated on European, but also on pan-European relations, like with Turkey and to Ukraine and to Norway. And again, just to mention that Estonia will join, I hope, in the next future. But the good news is that this month there is a discussion started between Eurocontrol and the Estonian government, so that Estonia joined also Eurocontrol. So, as I said before, my task is to keep you awake for the next hour. We will start by a video showing the traffic in Europe, keeping in mind that this is a 2006 video, and that this is just one-day traffic. We will start 2 in the morning, so this is the situation at 2 in the morning over Europe, and you will see that the traffic will increase to reach 3,000 flights during the day. So the transatlantic flight starts during the night and arrived around 4 or 5 in the morning. It starts. So in red, it's the aircraft flying less than 300 nautical miles. It's inter-Europe flights. 8 in the morning. It's not the peak. can see the traffic around the main center of Europe, big airport, so Paris, London, Frankfurt, and Milan in the south. Then we change the view to see the vertical view. So what I wanted to say by this video is that the traffic is really important in Europe, and we think that this traffic will more than double in the next few years. So our way how we are managing the traffic in Europe, the procedures, the tools, should also be improved. So we are almost at 8 in the night, so the traffic will decrease, and we reach the peak by 3 in the afternoon. As I have just said, the big challenge is that we think that the traffic will double by 2030. So for the capacity, there is a big challenge to handle the traffic. With the increase of the traffic, we should keep the safety as our main objective. The third thing is that also the environment is very important in all of this. And it's not only political, but we should take into account the environment with the increase of the traffic. We need to reduce the cost of the air traffic in Europe. As many of you know that in Europe the cost is very high compared to our colleague in the US. And we have to work on the fragmentation of the airspace. I will come back to this point later on. With all of this, there is a big need for improving the technology and also the interoperability. Because what we have today in Europe is that we have big manufacturers not talking to each other, and when an NASP buy a system, sometimes they are obliged to buy a big system that cannot be connected to other systems because of the interoperability problem. So at Eurocontrol, the main objective is the single European sky, but also we are working on the management of the network, which is composed of the airport and the en-route and approach. The third thing that we are doing at Eurocontrol is that we are doing real air traffic control, upper area of Maastricht. So the history started with the Maastricht area, and in the beginning we thought that all Europe will enter in this idea of the single European sky, but unfortunately many countries, they want to keep their sector as it is, and they didn't adhere at that time. But today there is new project that will change this, and we are speaking about the functional block, which will change a little bit this issue. We are the organism also responsible of the road charges, so we are collecting all the taxes that you are paying when you buy a ticket. This is go to Eurocontrol and then distribute to the country the route charges. And one of our activity, and this is the one where I'm working today, is the research program, CESAR pillar. And I will give some slides about CESAR later on. So some figures about the transport in Europe and the area that Eurocontrol manage in Europe. Eurocontrol is about 39 states. It's about 65 ACC, 600 sectors, some 16,000 controllers in Europe, and 36,000 support staff. This figure is not the people working for Eurocontrol, but it's the states which are members of Eurocontrol. The total revenue of the air traffic in Europe is about 7.6 billion a year. So it's an interesting domain for investors in the industry to enter this sector. How we are working with the European Commission and EASA to control. So the European Commission and EASA are responsible for the regulation with the ANSP, and we provide technical support and expertise for them as experts in air traffic management. The second role is the network management. Maybe you heard about the CFMU and the regulations that we manage in Europe. This is the role of the network management. And the third pillar is the research program, short, medium, and long-term research. If we go in depth and we speak about the airport and the relation of the airport and the network, you can see from this slide is that the airport generates a lot of delays. And when we speak about delays, we speak about loss of money for companies. And this is the area where we should enhance our work, is to decrease the delays in the airport. Unfortunately, the main issue in delays is the weather. The weather is responsible of about 45% to 50% of the delays in airports. But the new technology should allow us to work even in bad condition. So there is an area where we can work a lot in terms of systems, is this area. The capacity, there is a problem of the demand and the what we can provide as a service. So the capacity of the airport is related also to the runway and to the configuration. So we cannot provide as many slots as we want. And other problems related to the staffing, etc. So. And this is the growth of the traffic in Europe that we foresee. You see in 2010, this is the crisis, the decrease of the traffic, but it starts again to increase, and we think it will continue to increase in the future. So in 2006, in the traffic compared to the whole world, in Europe, we manage about 44% of the traffic in the world. And our forecast for 2036 is that we will manage 40% of the traffic. Keep in mind that in 2036, traffic will be the double, and the 40% in terms of number of traffic is very, very important figure. What I wanted to say also is that there is a big actor here, which is the Asia Pacific and the Middle East. You see, in 2006 it was about 16% the traffic there, and 1% for the Middle East. We think that it will increase to 25%. So Asia is really a place where the traffic will increase a lot in the next few years. I spoke about the capacity and the demand. Here is our forecast for 2030 about the demand. You can see that we will not be able to, with the current configuration, we will not be able to handle all the demand for the traffic, and especially in areas like Germany, France, England, Turkey, the demand will be 30% above than the capacity. So what we did at Eurocontrol is that we analyzed the different parameters. Where can we improve ourselves? Here is the problem how we stated. So we know that we have a lack on airport capacity, as I just shown before. We know that there are problems in crisis management, as you remember a few years ago about the volcanic ash. Some part of Europe showed that there is no real crisis management procedure in some places. The level of the safety related to runway operation, we should keep the safety very high. Sustainability related to societal need versus societal constraints. And this is one of the main problems that we have, is the lack of integration of airport into the network. Because a few years ago, when you speak about air traffic management, we speak about approach, en route, but not about airport. Airport is like a black box. The aircraft arrive, depart from airport, but it's not considered as part of network. This is also because the economic model for the airport is different from en route and approach. And the airport we have two contradiction is that company, they want passenger very quickly leave the airport to keep flights on time. And on the same time, we have the airport people, they want to keep the passenger as long as they can to buy things from airports. So it's very difficult to have a balance between those two big actors. And the last point is about the complexity of the airspace and its connection to the terminal. So you will see what we did at Eurocontrol to handle some points of this. So for the organization, there is the first act, which is about planning. And this is an area where there is not a lot of that has been done in the last years. And the concentration on collaborative planning is something really new. So in Europe, there are just 3 airports which have a real planning for the whole airport. And from those 3 airports, just 1 or 2, they are really doing this work. What I mean by the collaborative airport planning is the fact that before the aircraft arrive to the airport, the ground handlers, they know that the aircraft will arrive. They should, the controller knows when the aircraft will land, and this information should be shared between all the actors. Today, this collaborative work doesn't exist in all airports, and if it exists, it's not coherent in European level. So our answer to this problem is to put what we call AOP, Airport Operation Plan, to integrate the airport to the network so we can all share the same information, and to improve the current collaborative decision making. What I want by this presentation is to present the operational need, but also where the industry can intervene. In this particular point, for example, there are some industrial who are trying to help the operational to put on place systems on airport to do this, but not in all airports in Europe. There is Roissy Charles de Gaulle, Heathrow, and Munich Airport and Zurich. They have already did a lot of work on this, but all the other airports, it's in progress and maybe even not. The second point is about the runway management. I will speak a little bit about this problem of the runway management, because today, if there is something where there are a lot of things to be done, is on that area of the runway management, to detect the vortices, to help the controller to know how to space the aircraft. The third point is the surface management. So what we provide to controller in big airport today, the current situation is a radar situation, so he sees the aircraft moving on the airport, but he cannot see what will be the route that the aircraft will follow. And he cannot compare what's planned with what's executed. So this is the current situation. Of course, I will speak a little bit about what our proposal to improve this. And finally, the integrated tower working position. I'll show some photo about new airports in Europe, how they are. So regarding the AUP, the airport plan, what we want, as I said, is to integrate the airport in the whole network. And this is start by planification in the airport, which will be shared with the network. And then there is a mixture of all the information distributed to all the actors. So what we are waiting from the industrial is to put system in airport which enable the airport to share the information. It can be easy to say, but it has a lot of impact on airport because the complexity of each airport is different from the other. All the airports are not the same in Europe, and for each airport there is a specific case. I will go quickly on this slide just to show you what are the different actors that we have on airport. What we need today is that all the actors participate on the sharing of the information. So for example, when we finish furniture of the aircraft with foods, the actor signals this to the system and the control knows that the aircraft is ready for startup, for example. Even very simple things like this doesn't exist, which can be surprising. But this is the reality. And today, the people, they should talk and phone, they should speak to each other to share the information, which can be shared by a system, which doesn't exist on the airport. Okay, for the runway, how we are managing the runway today. There are 4 criteria to take in account to compute the how much distance should be kept between each aircraft. And the most constraining of the 4 criteria will determine the minimum safe distance to be kept. So the time distance can be reduced, but also uncertainty buffers. And for each of those 4 criteria, we need some system to help the controller for that. So I'll go to the next one to show you this. What we want to know today is how much the aircraft will occupy the runway, the time that will be spent on the runway to synchronize the traffic. What we are proposing today is that the aircraft itself inform the controller about the time that will occupy the runway. Once the aircraft send us this information via data link, the ground system compute the taxi routing. From this information, we can fix the route that the aircraft will follow on the airport, and the information is uplinked to the aircraft. Here, I'm not speaking about the system which exists. Here, I'm speaking about what we think should be done in the future to be able to handle an occupancy time on runways very, very little. I see that by half an hour, half of you is sleeping now. The second way is that we think that we can compute the taxi routing on ground, sending this via data link to the aircraft, which compute the occupancy time on the runway, send us back the information about how much it will occupy the runway, and then we fix the sequence. So, if we know exactly how much the aircraft will occupy the runway, we are able to say for the second aircraft when it should be depart. But there are other problems, as I said in a few slides before. The wake vortices, for example. You can see in the image the generation of wake vortices, and this is increase the separation between aircraft. As I'm speaking today, we can detect the vortices, but we cannot inform the controller of how much space he should keep between aircraft so that the second aircraft is kept safe. So the problem on this case is that we will put a big buffer around the separation. We lose time on the occupancy of the runway. And of course, when I said we lose time, we lose money. So this is also an area where a lot of can be done, because today there is no way to inform the controller how much space he should keep between aircraft in this case. So for radar, separation is 2.5 miles, but with the wake vortices it can go until 7 miles. The way forward, so we are working on this problem of wake vortices, but what we are expecting from the industry is to provide to the airport user, to the controller, new tools that allow them to decrease the separation between the aircraft. To not, if there are wake vortices, we should not keep a big buffer, but the exact buffer to keep safe the second aircraft. In the domain of the surface management, there are many other tools that can be developed also to help the controller. What we have today is just what we call ASMGCS, Advanced Surface Movement Guidance and Control System, which is just a radar picture of the situation. So what we are proposing to be developed in the future is the fact that we can provide to the controller the possibility to view the optimum route to the runway. So routing server is something which we think will be very important in the future and which doesn't exist today in modern tower. In this picture, what I'm showing is a mock-up that we are working on at Eurocontrol. This mock-up, the purpose is to show the idea, and then we think that the industrial can take this idea, those mock-up, to build the real systems. In this case, we show some proposal for the routing server. This first picture is what the controller has planned in white, and in green, it's what the controller has cleared, which is different from the first one. So the system can show to the controller the difference between what it was planned and what he has cleared. And you'll see why it's very important in terms of safety. Okay, I'll come back to this later. Just some photo about some interesting safety issue that you can see today. We have the safety expert here who can see how it's dangerous, this domain. In this case, for example, it's a runway which is occupied, but we have a landing military aircraft on a closed runway normally. Here we have two aircraft watching each other, so opposite side. This guy drank a lot of alcohol, so he went. And the Romanian also, I think, he missed the runway. This is more surprising because this is a taxi, so normally there should be no problem on taxiing, but the British Airways missed even the taxi. So what we did also is that we analyzed all the different situations that can bring us safety problems. And we addressed some proposal for enhancement of the safety tools that the controller have today. This MGCS level 2 is in operation today, but we think that the level 3 and level 4 should be implemented with taking into account the new systems, like the runway status light. This is a system that exists in the US. We start some tests in Roissy Charles de Gaulle, but not in all the other European airports. This is the kind of system that will help the pilot to know the status of the runway when he approaches the runway, either from approach or when he's taxiing. So he sees the light in front of him. If it's red, he should not continue. Even if the controller gives him clearance to continue, he will check with the controller, are you sure it's red in front of me? The third proposal is about the conflicting ATC clearances. So today, the controller can give two opposite clearances, but nothing in front of him can show him that there is a problem with his clearance. So he can give land clearance for an aircraft and at the same time cross runway clearance. This is something that happens very often, but the system today doesn't show him that he did a wrong clearance, or at least he should confirm that this is really what he wants to do. So we analyzed all the clearances given by controller, and we came with a proposal of how the system should behave to help the controller on this. The fourth proposal is to help take into account the routing of the aircraft, to show to the aircraft, to the controller, the non-conformance either to ATC procedure, the pilot didn't respect the procedure, or to the instruction, to the clearance. So here are some few slides about what we are proposing at support tools to the controller. Again, this is just mock-up. It's not system which is operational. This is what we are proposing for the community. And then what we are expecting is that the industry will take those ideas, develop them, build real system, and then sell them to the towers, or to the ANSP, or to any organism responsible of airport. This is the example of the runway status light. So once KLM start the takeoff, Crosshair sees the light on red in front of him. So Crosshair is lining up on this runway. He can see the red light, so he will never start his taking off before that this red light become green. It can be surprising, but in this runway, in this configuration, we had 20 people died 10 years ago because such system doesn't exist. What's happened with Spanish aircraft, it was on this Kilo 6. The pilot asked him to line up, and there was another aircraft sitting here. The pilot gave takeoff clearance. The guy here thought that the takeoff is for him, and the Spanish thought that the takeoff is for him. And then the big aircraft hit the small one on the runway in Roissy Charles de Gaulle. So based on problems like this, we analyze what we need on the system side to help the controller. Just 5 minutes left, so I'll go quickly. This is to show also the system of runway status light, so that we put red light around the runway, so the aircraft will not enter. This is an example of conflicting ATC clearance. So here the controller asks the Delta airline to take off on this runway, and on the same time there is a shamrock crossing the runway. It can be seen as a safe situation, so he will accept this kind of situation. But our role is to analyze that a takeoff clearance and the crossing on the same time should not be allowed normally. So the system proposed to the controller, are you really sure that you want to do this, crossing and takeoff on the same time? And this case where he can say, okay, I accept this because it's safe. The third example is the non-conformance to ATC instruction. So, as I showed before, the routing system showed to the controller what's the route that was cleared in green. And the system detects that an aircraft is not respecting the clearance that was given. So, KLM took the first to the right. It didn't continue ahead. So, we informed the controller of this route deviation. This aircraft didn't respect the clearance. It's really by chance that everything is KLM today. It's not So non-conformance to ATC procedure. Here we have a car which will enter the runway without a clearance. Another system that will allow us in the future to improve the situation awareness is the uplinking of the routing via data link. So the controller can send like an SMS to the aircraft with the complete route that he should follow. And this will avoid us the problem of English speaking. He didn't understand very well the route that I gave him and such kind of problem. So we are working also on this kind of mock-up to test with pilots from Airbus and other company usability of such system. And the avionic side, of course, they are improving also the avionic to receive those data link message on airport. Another system is to show the green light on all the airport for the aircraft. So this is something that exists today, but it's not implemented in Europe. It's to ask the aircraft to follow the green. So the controller will clear the route, and in front of the aircraft there will be a green light, show him where he should go. Another case that it's investigated, and especially for the north part of Europe, is the remote tower control. So with our colleague in Norway and Sweden and Finland, we are working on remote tower, so that with new systems, with video and enhanced visualization, we think that it's possible in the future that the tower, the building that we see today near the airport, we will not need them anymore, because we can show to the controller even a better visualization of what's happening in the airport. And this is another project where technology is very, very important. Some controller will not be very happy with what I'm saying, but this is a big discussion also. So some photo of the Malmö tower, remote tower prototype. This is again a prototype. It's not an operational system. In Malmö, they can visualize live the traffic in an airport which is in the north of Sweden, I think, and they can have even an enhanced visualization of what's happening on the airport. Okay, this is the slide about a new tower. This is in Heathrow, the latest tower that they built in Heathrow. And what you can see in Heathrow, for a controller, the number of screen that he has to manage and to visualize. This is really huge. Unfortunately, it's not well seen here, but there are 3 mouses. So the controller should also know which mouse goes with which screen. And we think that this kind of thing is not really correspond to what should be done on the tower today. With the information technology management and the advancement that we have, we think that all those screens can be integrated together. So we did a proposal at Eurocontrol, and we started the project in 2006 with 6 different NSP in Europe. We take the controller in the loop. They give us their feedback, and we build a mock-up to finish with this screen. This is a colleague from England, and in just one screen we can integrate the information that can be in 4 or 5 screens. This is also an area which a lot of improvement can be done, which we need industry to work on, and we need to convince them that this is the future. Not only building a separate system, but also to try to integrate systems together. Okay, quick word about CESAR. This is the program that was funded by European Commission and Eurocontrol. The idea is to have a research program in which we handle all those issues. So the goal of CESAR is to handle 3 times more traffic than 2006 figure, to improve the safety by factor of 10. Okay, I cannot answer what's a factor by 10 in safety. It's very difficult to see. With the increase of the traffic, we need to reduce the environmental impact by 10% and to decrease the cost by 50%. This is the 4 main objectives of CESAR. So, by European Commission and Eurocontrol, they funded this CESAR program, putting 700 million euro each, and the industry, the big industrial, who were funded members also, participated with 700 million. So with a budget of 2.1 billion euro, we are running a program that should stop on 2016 to propose to the industrial what are the systems of the future. So for any industry who is interested about what can be done in Europe in the future, this is a very interesting program where to look. In this program, many actors are involved, staff association, airborne industry, etc. One picture of the industrial and the people participating in the program. The good thing is that in July 2010, other members joined the CESAR program, and last year also other industrial and people joined the program. So the doors are open. The time is finished, so I will stop here, but I'll give you just one slide about the system view, which can be interesting for you. So the main idea is to build a network in which the information is shared, and then we build systems around this to help the controller improving and reaching the 4 objectives of the CESAR program. So if you want, I will put this for the disponibility of anyone who is interested by this architecture of the CESAR program. So for the summary, the first point, Estonia is welcome to join Eurocontrol, I hope by next year. The ATM in Europe is very complex, but there are a lot of potential of improvement. The airport domain is very important in the ATM network, but also an attractive domain for the industry. There are a lot of money there, but also there are a lot of things that can be done. The CESAR objectives are very ambitious, the 4 objectives that I talked about, but we need to achieve them because it's very important for Europe to reach the objective of CESAR. And the last point, CESAR provides a good basis for system development and a chance to develop new tools for the ATM network and the ATC. I hope that this presentation gives you a better idea of what we are doing at Eurocontrol and different programs. Thank you.
Kas on küsimusi saalist? Jaa.
Jan, Rector. I would like to put my question now, but I expect the answer during the panel session because it's not that easy to answer, I hope. Because as we are here, the representatives of Estonia and different kind of industries here who expect to cooperate with the European manufacturers, then we'd like to know how the Estonians, what is your view, how the Estonian manufacturers could work together with those system manufacturers, as you described here, which are really complex ones. But it's not that short answer, so please, I know that we have the panel session and we can discuss it more in detail later. Thank you.
Thank you for your questions, very interesting, but as first thought, the objective of this presentation is to show you that the potential is very important. There are a lot of potential for any industry to enter this market. It's not a closed market as many people think, because it's true that Thales, Selex, and those industrial are big industrial, but they don't invest a lot on new technology because it costs also. And the purpose of this is our program is to put money to enhance the research, to bring the new tools. So there is a potential where the industrial from Estonia, for example, they can enter, because if you build a system which can be operational, which respect the quality, which respect all the ANSP requirement, the big industrial has, and it's not something new, if you are bringing something that can be useful, the bigger they will try even to take you on board. So what we are doing also in this program, Cesar, is that we are working a lot on interoperability. So that when I'm building my tower in Estonia and I will buy the system from Thales, I have always this possibility to buy small system that can be integrated on the big one from an Estonian company. Why? Because the Thales system doesn't allow me to do routing, for example, display. So I hope that.
Okay, we'll leave further questions for the panel discussion.